Now let us start the class, sir. Please write down the heading. Put a star mark and write down the heading. How to find the last two digits of any number. Do not miss any single type whatever I am discussing in today's session, because if you miss any single type you will end up losing the entire content, because every type is interrelated with the next type. How to find the last two digits of any number. Very, very important topic. We will see how beautifully we can solve some of the toughest questions in the most easiest way possible. Now we will discuss type by type. Please write down type 1. How to find the last two digits of any number. In that type 1 is when the unit digit is 1. When the unit digit is 1. How to find the last two digits of any number when the unit digit is 1. Now listen to this carefully, sir. Do not write anything. I will give you sufficient time for you to write. Just keep on listening to my class. If you listen to my class carefully, probably I will make you solve, or I will make you create questions on your own, so that you can create questions and solve your own questions. Listen carefully, sir. Type 1 is when the unit digit is 1. What is the meaning of unit digit? Unit digit is nothing but the last digit. Suppose for example, I have a number 31. Right, I have a number 31. What is the unit digit of 31? Unit digit of 31 is 1. That is my type 1. I am interested in finding the last two digits of 31 to the power of 48. Right, I am interested in finding the last two digits of 31 to the power of 48. What is the meaning of 31 power 48? 31 power 48 is nothing but 31 into 31 into 31 multiplied how many times? Multiplied 48 times. That means if I multiply 31 48 times, I will end up with a very, very bigger number. But I am interested in finding the last two digits of that bigger number. That is my topic today, right? Finding the last two digits of that bigger number. Now listen to this carefully, sir. It's a two-step approach. Step number 1, step number 2. Listen to this carefully. Step number 1. What is the unit digit in the base? Unit digit in the base is 1. 1 power any number is how much? 1 power any number is 1. That means unit digit in the answer also will be 1. That is my step number 1. Step number 2. What is the tens place in the base? Tens place in the base is 3. What is the units place in the power? Units place in the power is 8. Multiply both of them. What is 3 into 8? 24. In 24, what is the unit digit? 4. That 4 will come as the tens place in the answer. That means last two digits of 31 to the power of 48. How much it is? It is 41. Again I am repeating, sir, for the people who did not understand. I am taking a number 31 where the unit digit of 31 is 1, which is my type 1. I am raising it to some random number called as 48. Listen carefully, sir. I am interested in finding the last two digits of 31 to the power of 48. Unit digit in the base is 1. 1 power any number will always give me 1. That 1 is the unit digit in my answer. Second step. Tens place in the base is 3. Take down the 3. Units place in the power is 8. Take down that 8. Multiply both of them. 3 into 8 is 24. In 24, what is the unit digit? 4. That 4 will come as the tens place in my answer. That means last two digits of 31 to the power of 48. How much it is? It is nothing but 41. One more example if you are not clear. Do not worry about the number of questions which I will be taking. I will keep taking as many questions as possible until it is very, very clear for my students. Suppose take any number where the unit digit is 1. Suppose for example 171. Take any power of your choice. Suppose for example 344. Same logic I will implement, sir. Unit digit in the base is 1. 1 power any number is 1. That 1 should be the unit digit in my answer. That is my step number 1. Step number 2. What is the tens place in the base? It is 7. Tens place in the base is 7. What is the units place in the power? It is 4. Multiply both of them. 7 into 4 is 28. In 28, what is the unit digit? 8. That 8 should come as the tens place in my answer. That means the last two digits of 171 to the power of 344. How much it is? It is 81. I hope everyone is very clear, sir. It should be very clear for all the viewers who are watching this video. Tens place in the base is multiplied with units place in the power. Whatever the value which you are getting as the units place in the product, that will come as the tens place in the answer. Right? Now, try to tell me this answer, sir. I am more interested in creating more and more questions for you and making you create more and more questions on yourself. Suppose, for example, tell me this question, answer for this question. If possible, try to solve this question without using pen. I am damn sure that my students can solve it without using pen if you have understood the first two questions. Suppose, for example, 1, 2, 3, 4, 1 to the power of 1, 2, 3, 4. Tell me the answer, sir. Tens place, first of all, 1 power any number is 1. Tens place in the base is 4. Units place in the power is also 4. Multiply them. What is 4 into 4? 4 into 4 is 16. In 16, what is the unit digit? 6. That 6 should come as the tens place in the answer. Last two digits of this number is how much? 61. Right? Last two digits of this number is 61. Suppose, one more example before we move on to next type. Tell me the answer for this question. 7891 to the power of 1, 2, 3. What should be the answer, sir? 1 power any number is 1. Tens place in the base is 9. Units place in the power is 3. 9 into 3 is 27. In 27, what is the unit digit? 7. That 7 should come as the tens place in the answer. Answer for this question is 71. I hope it is very clear for all the students who are watching this video. I hope type 1 is clear, sir. I will slowly increase the level of difficulty and I will move on to some other types where the unit digit is changing. I hope everyone is clear with whatever we have discussed till now. Very good. Most of the students are getting the answer right. It's a just a 2 seconds answer or a 1 second answer if you practice little bit, sir. Just to tell you, just to inform you how this actually problem is solved. Suppose, for example, if I take this problem, 31 power 48. What are the last two digits which I got? Last two digits is 41. How is that? Actually, you will get it 41. Now, how is your textbook solving this 31 power 48? Let us also see that it is always good to know the other methods. If in case you forget that particular method which I taught, at least this will take care of you, but this will be very time consuming process according to me. 31, they will write it as 30 plus 1 power 48. 30 plus 1 power 48. It is of the form a plus b whole power n. Binomial expansion. nc0 plus nc1 a power 1 b power n minus 1 plus nc2 a power 2 b power n minus 2 plus nc3 a power 3 b power n minus 3. Like that it keeps on continuing until you get the last term, which is ncn. Right? Now n value, a value is 30, b value is 1, n value is 48. You will substitute a, b and n values here and you will keep on simplifying. You will get the answer probably after 4 to 5 steps, which is extremely time consuming method, which can actually be solved by using the method of Anil Nair classes way of solving within 1 or 2 seconds of time. Kindly avoid using these kind of methods which will actually kill your time, but it will not result in anything better than that. Right? We are not interested in that kind of methodology, sir. If you are such kind of a student who want to learn by using binomial expansions and other methods, you should immediately drop out from this channel. Right? 31 power 48, a beautiful method which make you solve some of the questions in less than 1 or 2 seconds of time. I hope it is clear, sir. I hope it is clear, sir. Everyone is clear? Waiting for your comments before I move on to the next one. Good to see all my old students coming back to the classes and listening to our classes. Very happy for you, sir. Yes. Very good. Most of them are clear. Now listen to this carefully, sir. Suppose, for example, suppose your question is find the last two digits of. Listen carefully, sir. I am just extending this type 1 to a next level. Find the last two digits of 1 plus 11 power 11 plus 111 power 111 plus 1111 power 1111. Right? 1111 power 1111. The last number is 1 written 9 times, right? 1 written 9 times to the power of, again 1 written 9 times, right? Now see here, it's a very difficult question if you don't know the concept. That is the reason so many times in many of the classes Anil sir will keep telling that it is always good to know the concept rather than using formulas, right? Formulas will not make you to open all the doors, but concept will surely do it, right? Now let's see here how beautifully a very tough question can be solved by using this kind of methodology. I am interested in finding the last two digits. 1. The last two digits of 1 is 0, 1. I can write it as just 1. 11 power 11. I don't need to multiply 11 times to get the value of 11 power 11 and take the last two digits. Apply the same logic, sir. 1 power any number is 1. Tens place in the base is 1. Units place in the power is also 1. What is 1 into 1? 1 into 1 is 1. What is the unit digit in what is the unit digit in 1? 1. That should come as the tens place in the answer. That means the last two digits of 11 power 11 is how much? It is 11. 111 power 111. Same logic. 1 power any number is 1. Tens place in the base is 1, units place in the power is 1. Again it is 1 into 1, 1. It is 11. This also will be 11. And the last number, this value also last two digits will be 11. Right? This value also last two digits will be 11. Same logic I will implement. Check it out. Can I say that if it is the second number, it will have 2 ones. If it is the third number, it will have 3 ones. If it is having 9 ones, it will be the 9th number, right? It will be the 9th number. That means excluding this one, 11 is added how many times? 11 is added 8 times. 11 is added 8 times means it is 11 into 8, 88. 88 plus 1, it is 89. Last two digits will be 89. How much time it will take for you to solve this very tricky question, sir? It actually takes within probably less than 5 seconds of time for you to solve this question, and that is only possible by using the concept, not by using formulas. Kindly avoid using formulas. I have seen so many students using formulas. The worst thing is we as a student probably will by heart thousands of formulas, but remember only 100 formulas, and in the examination we will only vomit 10 formulas. What is the use of by hearting 1000 and vomiting only 10? Kindly avoid using formulas. Let us go the other way in learning solving problems through Anil Nair classes way of solving. I hope everyone is clear with the logic whatever I have discussed in type 1. Clear, sir? Rahul says it is clear. Everyone clear? Ramesh says it is clear. Type 1. How to find the last two digits of any number when the unit digit is 1. We are interested in taking unit digit type by type. First type says that unit digit is 1. Let us see what will happen if the unit digit is a different number other than 1. Shruti says clear. Basant, Babita, everyone says very clear. Good, sir. Next. Type 2. Type 2. Now listen to this carefully, sir. Before moving on to type 2 problems, there are few things that you need to know before solving type 2 questions. Listen carefully, sir. Please understand these key points. These key points will help you solve type 2 questions in the most easiest way possible. Now listen carefully, sir. Suppose for example, I have a number called as 15. Suppose I am taking a number 15. I am dividing this 15 by 4, right? I am dividing this 15 by 4. I will find the remainder, right? I will find the remainder. What is the remainder when 15 is divided by 4? If I divide it, 4, if I divide 15 by 4, 4 into 3 is 12. What is the remainder? Remainder is 3. That remainder 3 is nothing but my positive remainder, right? Positive remainder is nothing but 3. Now, I want to introduce a new concept for you called as a negative remainder. Probably some of the students might have already attended reminders classes from Anil sir, but I will repeat it for this particular class once again. Negative remainder. Now listen to this carefully, sir. Positive remainder is 3. How did I find the positive remainder? Take a multiple of 4, which is closer to this number called as 15, but it is less than 15. What is a multiple of 4 which is closer to 15 and less than 15? It is 12. What is the difference between 15 and 12? It is 3. That is nothing but positive remainder. How to find negative remainder? Take a multiple of 4 which is closer to 15 but it is greater than 15. What is a multiple of 4 which is closer to 15 and greater than 15? It is 16. What is the difference between 15 and 16? It is 1. Write down 1, put a negative sign. Write down 1, put a negative sign. Just keep on listening, sir. Probably even if you know this concept of negative remainder, listen once again. It will help you tremendously well in your type 2 and other types. Suppose for example, I have a number 17. I will divide this number by 5 and I will find the remainder. 5 into 3 is 15. Take a multiple of 5 which is closer to 17 but less than 17. It is 15. Difference between 15 and 17 is 2. That is positive remainder. Negative remainder. Take a multiple of 5 which is closer to 17 but it is greater than 17. How much it is? 20. What is the difference between 17 and 20? It is 3. Write down 3, put a negative sign. Write down 3, put a negative sign. Now, instead of understanding like this, listen to another way of understanding, sir. Listen to this carefully. Can I say that, suppose for example, assume that I know positive remainder as 3, right? Assume that I know positive remainder. Suppose if I know positive remainder, if I have to find a negative remainder, subtract with the denominator. What is 3 minus 4? 3 minus 4 is minus 1. That is what I got here. What is 2 minus 5? 2 minus 5 is minus 3. That is what I got here. That means if I know positive remainder, to get negative remainder, subtract with the denominator. Reverse is also true. If I know negative remainder, to get my positive remainder, add it with the denominator. What is minus 1 plus 4? It is 3. What is minus 3 plus 5? It is 2. Again I am repeating. If I know positive, to get negative, subtract with the denominator. If I know negative, to get positive remainder, add it with the denominator. Right? I hope it is clear, sir. Add it with the denominator. Now, the first two examples, whatever I have taken here, observe carefully. Numerator is 15. Denominator is 4. Numerator is greater than the denominator. Second example, numerator is 17, denominator is 5. Again numerator is greater than denominator. First two fractions which I have taken as examples, they are improper fractions, right? They are improper fractions. What if it is a proper fraction? Listen carefully, sir. Everything what I explain, I will connect with the dots. If I am not connecting, you should question me. Simple, right? Now see here. Suppose for example, let me take a case where numerator is less than the denominator. 37 is divided by 40. I want to find the remainder. Now see here. If I divide 37 by 40, 40 into 1 will become 40. It is exceeding 37. So it is not into 1. Suppose if I multiply with 0, 40 into 0 is 0. What is the remainder? Remainder is 37. That means positive remainder is 37. Right? Positive remainder is 37. Just 2 minutes before I told you a statement. If I know positive remainder, to get the negative remainder, subtract with the denominator. What is 37 minus 40? It is minus 3. Right? 37 minus 40 is minus 3. That means, can I conclude like this? Observe carefully, sir. Whenever numerator is smaller than the denominator, numerator is 37, denominator is 40 in this example. If the numerator is smaller than the denominator, numerator itself is my positive remainder. Right? Numerator itself is my positive remainder. My negative remainder is nothing but numerator minus denominator. What is 37 minus 40? It is minus 3. Right? I hope it is clear. Tell me the answer for this. I am sure that you should tell me the answer for this without using pen. Remainder when 56 is divided by 60. What should be the positive remainder? Numerator itself is the positive remainder, which is nothing but 56. Negative remainder is nothing but, whenever numerator is smaller than the denominator, negative remainder is nothing but numerator minus denominator. 56 minus 60 is how much? Minus 4. I hope everyone is very clear with whatever I have discussed till now. I hope it is clear, sir. There is no what do you say, like you need not take too much of tensions in solving problems on last two digits, unlike the way it is solved in your textbooks with so many steps. You can simplify the problem to a very smaller extent and get the answer within 5 to 10 seconds of time. Just keep on listening to my class until all the types are completed, sir. You will learn a lot of beautiful things probably you might have not heard before. I hope everyone is clear with this positive and negative reminder. If positive reminder is known, subtract with the denominator to get negative. I hope it is clear. If negative is known, add it with denominator to get positive. Now see here. That is one key point that you need to know. This is first key point that you need to know. Second key point. You should also know another key point for us to simplify our problem to a greater extent in type 2. Now see here, sir. Second key point. Suppose for example, I will take some number. For example, I am taking a number 123. Take any random number, whatever you like. I am taking some random number 123. Now, what are the last two digits of 123? Last two digits of 123 is how much? It is 23, right? Last two digits is 23. Now, listen to this carefully, sir. Last two digits is 23. Now, what I will do is, I will take the same number 123. I will take the same number 123. I will divide it by 100 and I will find the remainder, right? I will find the remainder. What is the remainder when 123 divided by 100? 100 into 1 is 100. Remainder is how much? 23. That means, can I say that these two are same? These both are same, right? Can I say that those both are same? That means, can I conclude that take some random number n. Instead of 123, take some random number n. Divide that number by 100. Find the remainder. Whatever the remainder that you will get when you divide that particular number by 100, that remainder is exactly same as last two digits of that particular number, right? Very important key point. Last two digits of any number n is nothing but equal to remainder when you divide that number by 100. Very important. Last two digits of any number is remainder when you divide that particular number by 100. I hope everyone is clear with this logic, sir. Remainder when you divide that number by 100 is nothing but equal to last two digits of that number. Everyone clear? First key point is you should know what is a positive remainder, what is a negative remainder. Second key point is last two digits of a number is defined as remainder when you divide that particular number by 100. I hope it is clear, sir. I am waiting for your comments in live chat so that I can move on to type 2 to simplify the problem to a greater extent. Siddhant, I will provide our number, sir. You can message us. We will add you to a WhatsApp group so that you will get the live updates of when the classes will happen every day. Basant, same is the case with you, sir. You can wait till the end of the class to know more about it. Very good. Most of the people are very clear with the logic. Next. Excellent, sir. Very good. Now listen to this carefully. Type 2. Write down the heading. Type 2. Type 2. Type 2 is when the unit digit is type 2. When the unit digit is 9. Keep listening to my classes, sir. I will give you tsunami of confidence in aptitude in the next probably 10 days of time. We are planning a lot of initiatives in the next few days. You will learn some of the best beautiful shortcuts to simplify the problem to a very greater extent. Type 2. When the unit digit is 9. Now, listen to this carefully, sir. Listen to this carefully. Do not write anything. Listen to this carefully. Take any number, whatever you like. Suppose, for example, I take a number 79. Why 79? Unit digit is 9. That is the type which I am discussing. You take any other number where the unit digit is 9, right? Suppose 79. Power, you take any power of your choice. For example, 34, right? Listen to first problem carefully. If you understand first problem, probably the next 2-3 problems you will tell answer very fast. Now see here, sir. I want to find the last two digits of 79 to the power of 34. Just 2 minutes before I told you a statement. Last 2 digits of any number is nothing but take that particular number, divide that number by 100, find the remainder. 2 minutes before only we discussed this, sir, not too long ago, right? Take that number, divide that number by 100, find the remainder. Now see here, I already told you that forget about this power 34. 79 is the numerator, 100 is the denominator. Numerator is less than the denominator. Apply negative remainder concept. Whenever numerator is less than denominator, negative remainder is numerator minus denominator. 79 minus 100 is how much? Minus 21. Write down minus 21. Write that power 34 as it is. Now observe carefully. Negative number to the power of even power is positive. It is 21 power 34. 21 power 34, you already know it, sir. That is nothing but type 1, where the unit digit is 1. We already discussed so many questions. What should be the answer? 1 power any number is 1. I am repeating for the people who joined probably little late. 1 power any number is 1. Tens place in the base is 2. Units place in the power is 4. Multiply 2 into 4 is 8. What is the unit digit in 8? 8 itself. That should come as the tens place in the answer. Answer is 81. That means any question which you come across in type 2, you should definitely take care of type 2, because you should know type 1 also. That means type 2 is definitely interlinked with type 1, because there is a concept called as a negative remainder. So do not ignore type 1. If you are ignoring type 1, you are indirectly ignoring type 2 also. I hope it is clear, sir. New world. Why we have to divide with 100 for every number, sir? I already discussed that logic, sir. That is for the simple reason that last 2 digits, the definition is remainder when you divide that number by 100. I will come back to that point in new world. I will take 2 to 3 new examples of this type and I will come back to that point. Suppose for example, tell me the answer, sir. 69 to the power of, put any power of your choice, sir. 144. Now 69 power 144, last 2 digits is remainder when you divide 69 power 144 by 100. But don't keep writing this point again and again in your examination and waste your time. You might take probably 5 seconds in writing this point. That is only 5 seconds. But still that 5 seconds is extremely important in so many other problems. Don't waste your time by writing unnecessary steps. 69 by 100. That means 69 minus 100. Negative remainder is minus 31 to the power of 144. Negative number to the power of odd number, it is positive. It is 31 to the power of 144. 31 power 144 is type 1. Simplified, sir. 1 power any number is 1. 3 into 4 is 12. In 12, what is the unit digit? 2. Answer should be 21. As simple as that. Do not break your head too much. Right? Now see here. Suppose for example, tell me the answer, sir. Suppose if it is 49 to the power of 368. Right? 49 to the power of 368. 49 negative remainder is 49 minus 100 is minus 51 to the power of 368. Negative power even is positive. 1 power any number is 1. Write down. 5 into 8 is 40. In 40, unit digit is how much? 0. It is 01. I hope it is clear. Answer is 01. Now, in this type 2, you might get 2 doubts. What are the 2 doubts that you might get? First doubt that you might get is, what if the power is an odd number? Everywhere, whatever the power which I have taken till now in the first 3 problems is an even power. What if the power is an odd power? That is the first doubt that you might get. Second doubt that you might get is, what if it is more than 2 digits in the base? Everywhere I am taking only 2 digits. What if it is more than 2 digit number in a base? These are the 2 doubts that you might encounter. Now, listen carefully, sir. Beautiful learning, sir. This is the reason you need to keep listening to Anil Nair Classes YouTube channel. As simple as that. Now, see here. 79 to the power of 34. Let me take the same question. Right? 79 to the power of 34. What are the last 2 digits which I got? I got it as 81. I will write it here once again. 79 to the power of 34. I got the last 2 digits as how much? 81. Now, not only 79 power 34, sir. You take it as 179 to the power of 34. Still it is 81. You take it as 3179 to the power of 34. Still it will be 81. You take it as 2343179 to the power of 34. Still it is 81. That means, what is that we are doing here? We are interested in finding the last two digits of a number. Because we are interested in finding only the last two digits, I am least bothered about the remaining digits. I am interested in only picking the last two digits in the base also. I hope it is clear. That means before this digit 79, before this number 79, let there be 100 or 1000 or n number of digits. I really don't mind about it. It really does not make any difference how many digits are there in the base. I am only interested in taking the last two digits from the base, right? I hope I have answered one of the doubts out of two doubts which you might encounter. Now, what is the other doubt which you might get, which I only created a doubt in you people? What if the power is an odd number, right? What if the power is an odd number? Suppose, for example, let me take 79 to the power of 123, right? Power is an odd number. Listen carefully, sir. Same logic I will implement. 79 negative remainder is minus 21. Minus 21 to the power of 123. Negative number to the power of odd power is negative. Keep that negative outside. This is the only difference between previous type and this type. Type in the sense I am talking about odd power and even power. Negative number to the power of odd number is negative. Write down negative outside. 1 power any number is 1. 2 into 3 is 6. Write down 6. Now, you got a negative remainder and I already told you the concept, sir. What is the concept? If you know negative remainder, if you want to convert it to a positive remainder, add it with the denominator. But in last two digits concept, denominator is how much? Denominator will definitely be 100 in last two digits concept. That means if I want to convert this minus 61 to positive remainder, add this minus 61 with 100. 100 minus 61 is how much? 39. Very simple way of solving questions, sir. Why do you complicate things? We are already living in a complicated world. Why to complicate so many things in problems of mathematics or aptitude also at least? I hope it is very clear, sir. That is the reason the two key points whatever I discussed before I started type 2 is extremely important. Whenever you get a negative remainder, add it with the denominator. But in last two digit denominator is always 100. Add with 100, as simple as that. I hope everyone is clear, sir. Repeat. Rohit Kumar. Which one you want me to repeat, sir? I believe that you are asking me to repeat this type odd power. Same logic, Rohit. Same thing. 79 power 123. 79 negative remainder is minus 21. Write down the power 123 as it is. Minus 21. Negative power odd power is negative. Keep it outside. 1 power any number is 1. 2 into 3 is 6. Write down that 6. This is something which we discussed in type 1, Rohit. I don't know whether you attended type 1. You were little late or you were early. I don't know, sir. Now, you got a negative remainder. When you have a negative remainder, add it with denominator. And denominator in last two digits is 100 by default, because last two digit definition is remainder when you divide that number by 100. Add minus 61 with 100. 100 minus 61 is how much? 39. I hope everyone is very clear with the concepts which we are discussing, sir. Type 2 will definitely eventually reduce to type 1. So please do not ignore type 1, which is one of the most easiest way to solve in the way which we have solved. Don't use binomial expansions, all those textbook methodologies, by using cyclicity concept, all those things which will create a lot of time or take a lot of time for you to solve it. I hope it is clear, sir. Waiting for your comments. Now, there is a student, New World. He asked me a doubt. Why we have to divide with 100 for every number? Now, simple, sir. Suppose, for example, I have number 123. What is the last digit of 123? Last digit of 123 is 3. That last digit is nothing but take that number, divide by 10. Find the remainder. 10 into 12 is 120. What is the remainder? 3. These both are same. That means if you want to find the last one digit, of a number, divide that number by 10 power 1. If you want to find last two digits, divide it by 10 power 2, which is 100. Right? If you want to find last three digits, divide it by 10 power 3. If you want to find last k digits, divide it by 10 power k. I am just generalizing because a student asked me a doubt, sir. Anyway, we are not interested with k digits, which will not come in your examination also. In this particular class, we are only interested in finding the last 2 digits. I hope new world it is clear, sir. If Sid Sahu says it is clear, most of them says it is very, very clear. Next, type 3. Type 3. Listen to this very, very carefully once again, sir. Again, same implementation. Before solving type 2, we learnt something. Before solving type 3, we will also learn something. Then our type 3 becomes a cakewalk, right? Now see here, sir. Listen carefully. Key point or a note. Now see here. Suppose, for example, suppose you take some number whichever comes to your mind. Suppose I am taking the number as 4. I am calling that number as x, right? I am taking it as 4. Now this is very important key point. Listen carefully, sir. I will square this number. It becomes x square. X square is 4 square 16, right? X square is 4 square 16. Now what I will do is, for this x I will add 50. 50 plus x is 50 plus 4, 54. I will square this 54. 54 square, if you want, check it out, 2916. What are the last 2 digits of 54 square, which is 2916? Last 2 digits is 16. This is again 16. Instead of adding 50, subtract 50. 50 minus 4, 46. I will square it. 46 square also, check it out if you want. Last 2 digits will again be 16, right? People who have attended simplification class today from 3 o'clock of Anil sir, he taught you how to find the square of a number, cube of a number. You can find the square of 46 very easily by the method he has taught you, right? Now, I added 50 for x. I subtracted 50. Let me add 100. 100 plus x. 100 plus 4 is 104. I will square it. 104 square also will have last 2 digits as 16. Check it out if you want. I will subtract 100. 100 minus x is 100 minus 4. 96. I will square it. 96 square. 9216. Last 2 digits is again 16. Now hold on, sir. What are we doing here? Let us hold on for a minute to understand what are we doing here. Now see here, sir. Can I say that I took a number called as x, right? I took a number called as x. I added 50. I subtracted 50. I added 100. I subtracted 100. I added 150. I subtracted 150. I added 200. I subtracted 200. That means for this particular x, I am either adding or subtracting multiples of 50. 50, 100, 150, 200. All these are multiples of 50, right? For x, I am either adding or subtracting multiples of 50. After adding or subtracting multiples of 50, I am squaring all those values, right? I am squaring all those values. When I square all those values, whatever the value which I am getting as the last 2 digits, when I square all those values, that last 2 digits is exactly same as last 2 digits of x square. These both are exactly same. That means, can I say that x square and multiple of 50 added or subtracted with x, right? Multiple of 50 added or subtracted with x and then squared, both will always have same last 2 digits. Very, very important point. X square and 50k plus or minus x whole square, both will always have same last 2 digits. You can reduce some of the tricky questions to a very easy question using this important key point. X square and 50k plus or minus x whole square will definitely have their last 2 digits the same, right? Now this is the property, or this is the theory part. Let us see the application part for you to understand better. We are still not moving on to type 3, sir. I am still in the key point only. I want to solve 3 to 4 questions for your better understanding. Now see here. Suppose, for example, find the last two digits of 2389 whole square. Step number 1. 2389 is ending with 9. You can apply type 2. You can solve by type 2. That is one of the method of solving. That is something which you know already how to solving. Or another way of solving. Observe carefully, sir. Can I say that because I am interested in last two digits, these digits are waste. 2389 whole square and 89 square both will have same last two digits. This 89 square is similar to x square. Now for this particular x, which is 89 in my example, I will add 50. If I add 50, 89 plus 50 is 139. But 139 square is too much complicated for me. So I will not add 50. Subtract 50. 89 minus 50 is 39. If you know 39 square as 1521, take the last two digits as of 1521 as 21. Answer should be 21. But if you still don't know 39 square, no issues. Do not worry. Add 100. 100 plus 89 is 189. You are making too much complicated, sir. Don't add 100. Subtract 100. What is 100 minus 89? 11. That means 11 square and 89 square both will have same last two digits. And I am sure that you should know 11 square value as 121. What are the last two digits of 121? 21. Answer for 2389 whole square last two digits should also be 21. I hope it is very clear, sir. I will take few more examples. Do not worry about it. I will take few more examples for your better understanding. Suppose for example, now try to tell me this answer for this question, sir. Suppose 1, 2, 3, 4, 8, 6 whole square, right? 1, 2, 3, 4, 8, 6 whole square. These are all waste numbers for me. It is similar to 86 square. Subtract with 100. 86 square and 100 square. Sorry, 86 and 100. What is the difference? 14. 86 square and 14 square both will have same last two digits. 14 square is 196. What are the last two digits of 196? 96. Over. Simple. Suppose. Tell me the answer. 1, 2, 5, 7, 4, 6, 5, 6 whole square. Everything deleted except the last two digits. This is nothing but 56 square. Now don't subtract with 100 and make it complicated, because 100 minus 56 is 44. If you know 44 square, yes, you can do it. No issues at all. But instead of subtracting with 100, subtracting with 50 is easy. 56 and 50, what is the difference? 6. 56 square and 6 square both will have same last two digits. 6 square last two digits is 36. Very easy, sir. It is very easy if you know the concept. That is what Anil sir kept on telling in most of his classes. Suppose, tell me the answer for this question. 1, 2, 1, 2 whole square. Now listen carefully. 1, 2, 1, 2 whole square. If I delete this 12, you are left with 12 square. Now don't use some other methods whatever we have discussed in first three problems and subtract with 100. What is 100 minus 12? 88. 88 square. Today only Anil sir took this problem 88 square in simplification. 7744. What are the last two digits of 7744? 44. But if you know 88 square, that is easy. Subtract with 50. 38 square. If you know 38 square, it is easy. But why to subtract? Don't even subtract. You already know 12 square value is 144. Write down 44. That means basically this method of finding the last two digits, x square and 50k plus or minus x whole square both will have same last two digits. This will be tremendously useful if you don't know square till 100. But if you know square till 100, this method is nothing but just telling the value directly for 86 square and writing the last two digits as 96. That means square till 100 if you know by some or the other way, which Anil sir told today to use the shortcut method till 75, which I saw the video also, right? It will be tremendously helpful, sir. Even if you don't know till 100, please know till 25, right? For all the people, it is just a caution for you people before your examinations. If you don't know squares, minimum till 25. If you don't know cubes, minimum till 15. You are in a big danger. That I will mark it with red ink. You are in a big danger, sir. I repeat, what is the meaning of knowing square till 25? Knowing square till 25 means, if I ask you 23 square, within a second you should tell it as 529, like the way you tell 6 square within a second as 36, right? If you cannot tell within a second 529, I assume that you don't know square till 25, right? 25 squares till 25 is must. You cannot keep solving 23 into 23 in your examination and waste your time. You should know some of the things to make your life so simpler, and that is something not a very big deal to learn square till 25. I hope I am making sense for you people. Yes, new world. You can also find the square root, sir. That is something which is away from our today's concept, right? I hope everyone is clear, sir.
Press the bell icon on the YouTube app and never miss another update.